All right, get ready, because today we're going deep on some brand new AI research from Meta.
Oh, yeah.
You know how we teach computers to understand language?
Yeah.
Usually it's like we feed them words.
Right.
Imagine going straight to the source.
Like,
Bytes.
whoa.
This sounds kind of wild, right?
It does.
But this new model, it's called BLT. It's actually doing that.
BLT.
Yeah, and it's really changing things up in the world of LLMs.
Large language models.
Exactly. Large language models.
That's so fascinating.
So these LLMs, they're usually built on these things called tokens, right?
Yeah.
Words or chunks of words.
Like Lego blocks.
Like Lego blocks of language.
Yeah.
But what if we could go even deeper?
Deeper.
To the most basic building blocks of information.
Like the atoms of language.
Atoms of language. Those bytes.
So that's where BLT comes in.
BLT, that's a Byte Latent Transformer.
Byte Latent Transformer.
So instead of Legos, we're talking atoms.
Mm-hmm.
But how does a model actually learn from something as abstract as bytes?
Well,
This paper mentions patches.
yeah, patches are BLT's big innovation.
Okay.
So the fixed tokens, it dynamically groups bytes into these patches based on their information content.
So it's figuring out.
You know when you're reading something, you kind of skim the predictable parts and slow down for the complex stuff?
Right.
BLT's doing something like that. Like simple sequences,
Right.
they get long patches, and then complex ones get shorter, more focused patches.
So it's like allocating attention.
Exactly. It's dynamic.
That's amazing.
Yeah.
So it's not just reading bytes sequentially.
Nope.
It's actually understanding the structure
It is.
of the information in those bytes.
Yeah.
Pretty wild. But does it actually work?
That's the remarkable part.
Like, can it compete with the traditional token-based models?
It can, and it does.
Really?
It matches their performance.
Wow.
And it's more efficient.
Much more efficient.
Which is a big deal, with LLMs.
Huge. These models need so much computing power.
Oh, tons.
So BLT is doing more with less.
Uh-huh.
But how much more efficient are we talking?
So this is the first time a byte-level model
Okay.
has been scaled to 8 billion parameters
8 billion.
and trained on 4 terabytes of data.
Wow.
Most byte-level models in the past struggled even at smaller scales.
That's incredible.
Mm-hmm.
So it's not just theoretical. It's
Right.
actually proving this byte-level approach can work at scale.
That scale.
But wait, there's more.
Oh, yeah.
Efficiency isn't the only advantage.
It's not.
The paper talks about improved reasoning
Uh-huh.
and long-tail generalization.
Yeah, so reasoning, that's the model's ability to make logical inferences,
Okay.
connecting the dots.
Right.
And long-tail generalization means it can handle unusual language patterns better.
So it's like BLT has a deeper grasp of language structure
Yeah.
because of this granular byte-level processing.
Yeah.
Not just crunching data faster,
Well,
but
yeah.
understanding nuances of language.
Yeah.
Like almost human-like.
Almost.
This is pretty profound.
Yeah.
Makes you wonder, could this be the future of LLMs?
It's a possibility.
Ditching tokens, going straight to bytes.
Yeah.
What are the implications here?
Big implication.
If BLT can learn so well from raw data,
Yeah.
could this unlock even deeper levels of language understanding in machines?
It could.
Think about it.
Mm-hmm.
Machine translation,
Yeah.
text summarization,
Right.
even AI writing creatively.
Oh,
So much potential.
so much.
It's really exciting.
It is. Welcome back.
We're back.
So we were just talking about data quality.
Yeah, and how important it
It's
is
so important for AI models.
for how they develop. And
Their capabilities.
but Meta's exploring something new.
Oh, yeah.
They're calling them large concept models.
LCMs.
Yeah.
LCMs, okay.
Totally different way of thinking about language models.
So we talked about bytes as like the building blocks of language.
Right.
How do you go bigger than that?
Well,
What are these concepts you mentioned?
So traditional LLMs, they work with tokens.
Right. Words or chunks. But LCMs, they operate at a higher level.
Okay.
Not just looking at the words,
Uh-huh.
but the ideas behind them.
So like instead of seeing the words birthday party,
Right.
graduation, wedding,
Mm-hmm.
the LCM would understand the concept of celebration.
Exactly.
That's powerful.
It is.
But how do they even define these concepts in a model?
It's complex.
Yeah.
So they're using this thing called sonar.
Sonar.
It's a sentence embedding space.
Okay.
It can map sentences from over 200 languages,
Oh.
spoken and written,
Okay.
into a shared semantic space.
So it's like a universal language of concepts.
Kind of, yeah.
That's incredible.
It is.
But how does it learn?
So they trained it to predict the next concept. in a sequence.
Not the next word.
Not the word, the concept.
So it's like predicting what's going to happen next in a story.
Exactly, but on a conceptual level.
And they use diffusion models for this.
Yeah, those have been popular for image generation.
Yeah, creating images from text.
But here they're using them to generate representations of concepts.
Within this embedding space. So taking abstract ideas and giving them form.
Yeah, so the model can manipulate them.
Combine them.
In new ways.
That's really creative.
Yeah.
But this all sounds pretty theoretical.
Sure.
Can these LCMs actually do anything useful?
Well, they tested them on summarization.
Okay.
And something called summary expansion.
So like taking a short summary
Yeah.
and making it more detailed.
Exactly, but staying true to the original concepts.
That's super useful for research.
Oh, yeah.
Or even just understanding a complex article.
Definitely.
And since these concepts are language agnostic,
Right.
could the model summarize in multiple languages?
It's possible.
Like, could I feed it a summary in Spanish
Yeah.
and get an explanation in English?
So they found it had impressive zero-shot generalization,
Zero shot.
meaning it could handle languages it wasn't trained on.
That's amazing.
It is.
It's like it understands something fundamental about language.
Beyond just words and grammar.
So working with concepts directly could be the key
It could be.
to unlocking new levels of understanding.
And generate.
It's a paradigm shift
Yeah.
away from those token-based approaches.
Big time.
Makes you wonder, what are the limits?
Yeah.
Could we create models that understand the world just like humans?
That's a big question.
A really big question.
Philosophers and scientists have been thinking about that for ages.
It's both exciting and daunting.
It is.
We need to be careful as we move forward.
Absolutely.
Understanding the risks.
And the ethical implications.
Because this power is undeniable.
It is.
But we need to use it for good.
For the benefit of humanity.
We don't want to create systems that could harm people.
Right.
This is a conversation we all need to have. Not just AI researchers.
Policymakers, ethicists, the public.
Because this will have a huge impact on our lives.
It will.
And we all need a say in how it develops. Now, speaking of societal impact, Meta has another paper about improving image captions.
Using synthetic data.
This research looks at language and vision.
Two key ways we understand the world.
It tackles a problem with image captioning.
The quality of those captions?
They often generate captions from scratch.
Yeah. Ignoring existing metadata.
Like alt text. The
Exactly.
descriptive text embedded in images.
For accessibility.
Seems like that would be valuable for captions.
It is.
So they argue we should use that existing metadata
Even if it's imperfect.
to create better captions.
So they use the alt text as a starting point.
Okay.
And then refine it using AI.
Like a rough draft polished by AI.
Exactly.
But how do we know these AI captions are better?
Well, they did human evaluations.
Okay.
Compared them to the original alt text.
And to captions generated from scratch.
And the results were clear.
The AI captions were better.
They were rated as more accurate, relevant, and informative.
Wow, so the human judges preferred the AI versions.
They did.
That's really something. AI improving on human descriptions.
In certain contexts.
What are the implications here?
I think it shows how important it is to use all available information.
Especially with multimodal data like images and text.
You don't always have to start from zero.
Like an archaeological dig.
Uh-huh.
Finding amazing artifacts right under our feet.
We just need to know how to interpret them.
And as AI gets more powerful,
Our ability to find meaning in data becomes crucial.
it's a new era of data exploration.
With AI as our guide.
But we need to be careful
Absolutely.
as we explore this new territory.
We need to be responsible.
Ensure these technologies are used ethically.
For the good of everyone.
For humanity and the planet.
Yes.
We'll dive into those ethical questions more in the next part.
It's an important conversation.
We're back for the final part of our deep dive.
Yeah, exploring all this amazing AI research from Meta.
From byte-level models to
AI that understands concepts.
even theory of mind.
It's been a wild ride.
It really shows how fast AI is evolving.
Yeah, the potential is incredible.
For how we interact with tech and information.
It's mind-boggling.
But let's take a breath for a sec.
Yep.
And really think about what we've learned.
Yeah.
What are the big takeaways for our listeners? Especially those who are already into AI.
Who want to stay ahead of the curve.
Well, I think the biggest thing is we're seeing a real shift
A paradigm shift.
in how we build AI specifically language models.
Those token-based approaches
They're being challenged
by these new methods.
that use raw data,
Concepts.
even different modalities like text and vision,
It's like we're moving beyond just mimicking language
to a deeper understanding
of how meaning works.
Exactly.
And it's leading to AI that's not just efficient
but more capable of understanding.
and generating human language.
In a way that's more like how we think.
Yeah.
Like with BLT, it's using byte-level processing,
And getting amazing performance,
making it more accessible.
less resource intensive.
And then the large concept models,
LCMs.
thinking about ideas,
Meaning,
not just individual words,
like we're teaching AI to think conceptually,
to grasp the essence.
not just the surface.
And that zero-shot generalization,
What cross languages?
that's
It
incredible.
suggests something fundamental about language.
But we can't forget the ethical side of things.
Right.
We've talked about data quality,
Mm-hmm.
the potential for bias,
It's important to remember AI is a tool,
a tool that can be used in different ways.
for good or for bad.
It's on us to shape how it impacts society.
The data we use,
The tasks we give it,
the safeguards we put in place.
it all matters.
As AI gets more powerful,
We have to ensure it benefits everyone.
fairness,
Transparency.
accountability,
We need a dialogue about the future of AI
a broad dialogue
with everyone involved.
technologists, researchers,
Policymakers, ethicists.
the public.
This has to happen now.
While these advancements are happening,
We can't wait.
until it's too late.
And it's also important to remember AI is powerful, but it's not magic
It's a tool,
to help us solve problems
not a replacement for human judgment.
or creativity or compassion.
Right.
We need to find the right balance,
To empower people.
not control them.
It's a delicate balance.
That requires constant dialogue
Collaboration.
and a willingness to adapt.
As AI keeps evolving,
This deep dive into Meta's research
has shown us the possibilities
and the challenges.
that lie ahead
We're at the start of a new era
in AI,
full of promise.
and some peril,
It demands our attention,
our critical thinking,
our commitment to building a better future,
where AI serves humanity.
and helps us create a more just world.
It's a challenge we have to embrace.
Because the future of AI.
Is the future of humanity.
Thanks for joining us on this deep dive.
It's been great.